Hello friends. In this lecture we will study the background and the regulatory foundations of ERTMS. We will see how the idea of a common European railway signaling system evolved over time, the key organizations involved, and the basic concepts of interoperability and interchangeability which are central to ERTMS. Treaty of Rome, 1957. The idea of a harmonized European railway system is not new. As early as 1957, the Treaty of Rome mentioned the need of a common trans-European transport system. However, at that time, this idea could not be implemented because each country had very different transport policies. Railways were nationally controlled. Technical and political coordination was extremely difficult. As a result, railway signaling systems developed independently in each country. Renewed political initiative, 1989. A major change occurred in December 1989 when the European Ministers of Transport took an important decision. Following this, the European Commission started a detailed analysis of train signaling systems, train control systems, and problems related to cross-border railway operation. This marked the real political beginning of the ERTMS project. Role of ERRI, 1990. At the end of 1990, the European Railway Research Institute, ERRI, took a key technical step. ERRI created a group of railway experts called A200. The role of this group was to analyze existing national ATP systems and to define the requirement for a future European train control system. This expert group laid the technical foundation of ERTMS. Cooperation Agreement, 1991. In June 1991, an important cooperation agreement was reached between railway industry, railway administrations, UIC, International Union of Railways, and ERRI A200 expert group. The goal of this cooperation was to establish basic specifications and to define common requirements for industrial development. This ensured that all stakeholders worked together from beginning. Initial technical framework. The project framework defined three major technical elements. First, EuroCab, new onboard equipment based on open computer architecture. Second, EuroBalance, a new discontinuous data transmission system used for track-to-train information. Third, EuroRadio, a continuous communication system used mainly for high-speed and advanced train control. These components later became the backbone of ETCS. Interoperability Directive, 1993. In 1993, the Council of the European Union published an interoperability directive. It was a very important legal step. The directive formally recognized the need for interoperability and decided to create a body responsible for defining technical specifications and ensuring interoperability across Europe. This gave ERTMS a legal and regulatory framework. Fourth Framework Program, 1995. In 1995, under the Fourth Framework Program, the European Commission established a global development strategy for ERTMS. The main aim was to prepare ERTMS for future implementation and to move from theory to real railway networks. This strategy was documented in the Master Plan of Activities. Validation phase. An important part of the Master Plan was the validation phase. The objective of this phase was to conduct large-scale tests, to test ERTMS in different countries, and to verify safety, reliability, and interoperability. Only after successful validation could ERTMS be deployed commercially. Formation of UNISIG 1998. In the summer of 1998, UNISIG was formed. UNISIG is a consortium of major European signaling companies including Alstom, Bombardier, Siemens, Alcatel, Ansaldo Signal, and Invensys. The purpose of UNISIG was to finalize the technical specifications of ERTMS/ETCS. Finalization of specifications 1999 to 2000. The ERTMS specifications were delivered on April 23, 1999. Finally signed on April 25, 2000 as ERTMS Class 1 specifications. This moment is considered for the official arrival of ERTMS as a complete and standardized system offering much higher performance than national systems. Interoperability success. After finalization, interoperability tests were conducted in multiple countries. These tests were highly successful. As a result, several commercial ERTMS projects were launched. Many projects received financial support from the European Commission. Commercial ERTMS projects. These are some examples of ERTMS projects. These projects demonstrated that ERTMS works reliably in real railway operations. Regulatory requirements. To regulate ERTMS implementation, two key documents were developed: FRS, Functional Requirements Specification, and SRS, System Requirements Specification. These documents define what the system must do and how the system must behave under all operating conditions. Role of ERRI. The FRS and SRS are freely available, controlled and maintained by the European Railway Agency, ERA. ERA ensures uniform interpretation of specifications and long-term interoperability across Europe. Basic concepts of ERTMS. ERTMS introduced two fundamental concepts in railway signaling: interoperability and interchangeability. These concepts are essential for understanding how ERTMS differs from national systems. Interoperability definition. Interoperability means that a train equipped with the ERTMS onboard equipment from any manufacturer can operate on tracks equipped with the ERTMS equipment from any other manufacturer. This refers mainly to the ability of different systems to communicate correctly. Behavioral interoperability. Interoperability also means identical behavior. Under the same conditions, all ERTMS onboard systems must behave the same. For example, if a train receives a red signal, the system understands it as stop and applies braking exactly as specified in regulations. GSM example of interoperability. A good example is GSM mobile communication. Phones from different manufacturers can communicate. SIM cards can be changed. Similarly, in ERTMS, core functionality is interoperable, even though displays, menus, or interfaces may differ. Interchangeability. Interchangeability means the ability to replace ERTMS components, use equipment from different manufacturers without a redesign. This prevents vendor lock-in, encourages competition, and reduces costs from railway operators. To conclude, ERTMS was developed over several decades. It required strong cooperation between European institutions, railway operators, and industry. Interoperability and interchangeability form the core philosophy of ERTMS, making it the foundation of modern and future European railway signaling. Okay, thank you.